Hey everyone, my name is Will Valida. I'm a software engineer and cloud architect. And in this video, we're going to talk about creating and using plugins with the Semantic Kernel SDK. Now, when we use the Semantic Kernel SDK, we use plugins that act as the building blocks for our AI applications. Plugins essentially define the tasks that the kernel should complete, and the kernel interfaces with large language models and run the plugins that we define. Plugins can include native code and natural language prompts, allowing us to use generative AI in our applications. Plugins give us the flexibility of defining desired behavior in our application, and we can create custom prompt plugins to fine tune our applications precisely as we need to. In this video, we'll talk about how we can create our own Semantic Kernel SDK plugins to accomplish different custom tasks. We'll also look at how we can use the built-in plugins from the Semantic Kernel SDK to create our applications. Now, plugins are fundamental to the Semantic Kernel SDK, as they define the tasks for the kernel to perform since they interface with the large language models. Plugins can be just native code and prompts that are invoked to the large language model that we're using. The great thing about the Semantic Kernel SDK is that it offers built-in plugins for common tasks that are ready to use. Plugins are essentially classes that defines a task that the kernel should perform. It can be made from a semantic prompt or native function code. To use a plugin, we can add it to the kernel and call it by using the invoke async function. The kernel will then run the plugin that interfaces with the large language model and return the result. Some examples of available built-in plugins include a math plugin, a plugin to perform mathematical operations, text plugin, a plugin to perform text manipulation, and time plugin, a plugin to get time and date information. The Semantic Kernel SDK also supports a templating language that allows us to complete tasks using natural language processing prompts. These are conversational cues that we pass to the large language models, shaping responses based on our queries or instructions. This involves providing rich instructions to guide the model to generate the desired response. Now, this is important since we need to provide clarity to our prompts to get the results that we want. So here are some tips to keep in mind when we craft prompts. Specific inputs yield specific outputs. Large language models will respond based on the input they receive, so having clear and specific prompts is crucial to get your desired output. Experimentation. Experimenting is the key to understand how the model interprets and generates responses. Even small changes can lead to significant changes in outcomes. The context matters. Large language models consider the context provided in the prompt. We need to ensure that the context is well defined and relevant to obtain accurate responses. Handling ambiguity. Ambiguous queries are always fun, but even large language models will struggle with them. So providing context and structure to avoid vague or unexpected results is an important thing to keep in mind. Also, and finally, the length of prompts. While large language models can process both short and long prompts, you need to consider the trade-off between clarity and brevity. Experimenting with the prompt length can help you find the right balance. One cool feature that we can implement for larger projects is the ability to organize our prompts into separate files and then import them into the kernel. For our own plugins, it's a good idea to create separate folders for our prompts. The Semantic Kernel SDK supports a prompt templating language with some simple syntax rules. We don't need to write code or import any external library. What the semantic kernel will do is pass your template and run the logic behind it. And this templating language supports adding variables, calling external functions, and passing parameters to functions. We essentially configure it using a config.json file. As the name suggests, this contains the configuration details for the prompt and is placed in the same folder as the skprompt text file. And it supports parameters like the type, considering the type of prompt, description, basically a description of what the prompt does. And this is used by the kernel to automatically invoke the prompt. We can also define input variables and also execution settings, which defines the settings for our models. So let's see this in action. What we're going to do now is jump to Visual Studio and build an application that's going to be using a fitness plugin. Okay, so let's see how everything works using an example. So in this demo, what we're going to do is we're going to build an AI agent that helps me build out an exercise routine. I like to keep active. I want to improve my general strength. So let's see if we can build an AI agent that kind of helps us build out an exercise routine. So what I've done here is I've created a console application to build my AI agent. I'm going to be using a large language model from Azure OpenAI. I previously created this in a prior video, which I'll add a link to in the notes below. And to use that model, I've included a bunch of settings in this app settings.json file. And that's going to include information for the deployment model I'm going to use, as well as the endpoint and key that I need to connect to Azure OpenAI. I won't show you those values because I've been roasted for it in a previous video. So what I'm going to do instead is I'm going to install the packages that I need. And the first package I'm going to add to this project is the Semantic Kernel SDK. So what I'm going to do, just going to do a lot of copy and pasting in this. I will explain the code as I go along. I'm going to first install that package. And that's the common package for all of the kind of core functionality for the semantic kernel. So that's installed, fantastic. Then the next one I'm going to use is the configurations package. So I can actually load that settings.json file. I'm going to use the JSON extension. I'm not going to include the pre-release, not yet. I'll explain why I had that clicked in a moment. So apply that. Cool. Looks like that's been installed for me. And then finally, what I'm going to do is install the plugins package. So there is a particular package that we need to use to actually use plugins. And at the time of recording, the packages are currently in pre-release. So if I click include pre-release, I can see all of these packages are just kind of in beta, release candidate, and alpha version. So I'll use the latest one for now. So just go ahead, apply and install that. Get rid of that, and that looks like it's installed. So if I look at my CS proj file, I can see all of those packages have now been installed. Fantastic. I'll go back into my program.cs file. I'll get rid of the hello world statement there. And what I'm going to do, I am going to copy and paste this into the program.cs file to avoid the clickety-clack of my keyboard and just save a little bit of time as well. Okay, I'll open that up because what I need to do is just suppress that for now. Awesome, cool. Okay, so what we've done in this code block, we're essentially loading our configuration here and adding our connector to Azure OpenAI. We then, on line 16, add I'll actually zoom in a little bit here. Give me a second, 110, there we go. Then we add a conversation summary plugin to our kernel, and that we are getting from our plugins.core package. And then we create the kernel to add the plugin. So now we can actually start to build out our prompt that will ask our large language model to provide a list of exercises that we want to receive back. So if I go string input, I'm going to copy and paste this actually. So just give me a second. Copy and paste that at the semicolon. Okay, so what I've done here, I'm asking a prompt to say, hey, I'm new to the gym. I want to learn about bodybuilding. Can you give me a list of leg exercises that are beginner friendly and help me build my leg muscles? And then what I'm doing is I'm using invoke prompt async to just kind of invoke that prompt against our kernel. So what I'm going to do, save that. I'll run a build, make sure everything's okay. Everything kind of should be. Yep, that build was successful, so let's run it. And if we're successful, here are our leg exercises that have been returned to us. So fantastic. We've received a response from the Azure OpenAI model that we passed to the kernel, which the Semantic Kernel SDK has connected to, and we've run our prompt. So now what we can do is we can actually improve the prompt by adding more specific instructions. So it's not enough to just say, okay, I'm just want some leg exercises. Personally, a personal goal for me is I want to make my legs stronger. So let's actually update the prompt to show me how many reps and sets I should do to increase my strength. So I'll actually add a little bit to my prompt further down here. So here, what we are actually doing is we're going to be refining our prompt a little bit to get a better response. So here, what I've done is I've added specific instructions here to say, tell me how many reps and sets I should do to increase my strength, and then display the exercises in the following format. So I want the exercise there, and I also want the reps and how many sets I want to do. So let's go ahead and run that. Expand that a little bit. And here is our response. So see how the response has been a little bit, has been changed a little bit, and then it's been returned to us in a specific format that we asked it to. So here we got bodyweight squats with how many sets and how many reps. So it's been added in that format, and we've also got a little bit of more information from our prompt. We can improve this even further by adding a little bit of background information. So I'm just going to close that. So I'm not really new to the gym. I have been going to the gym for over 10 years now, roughly. So what I can do is I can just add that as a string. So I've provided a little bit of a background. So what I want to do is I'm just going to remove this. And I'm going to just get some real estate going here. So I want to say, consider the weightlifters background. I'm going to pass that in using string interpolation. So now what I'm doing is, okay, consider the background of the user. I want you to give me a list of leg exercises that are, I'm going to remove beginner friendly. And I'm just going to say that will help me build my leg muscles. I'll give a question mark as well since we're asking a question, and then tell me how many sets and reps I should do to increase my strength, and display the exercises in the following format. Cool. So let's run this again. So here we're trying to refine the prompt, make it a little bit more precise to get a bit of a better response from our large language model. And here it is. Okay, so yeah, that looks kind of familiar, or similar, I should say, to my current leg workout. So yeah, now that we've actually got a little bit more of a refined response, simply by just kind of adding more detail and more clarity to our prompt. Now, what we can actually do to improve the quality of our responses that are generated by our large language model is to add a persona to our prompt. So to do this, let's update our prompt a little bit. So what I'll do, actually add a little bit more space here. So I'm going to say, you are a fitness instructor. You are friendly, positive, and like to give as much detail as possible. There we go. Okay. So now what we've done here is we've given our agent a little bit of a persona. So if I run that now, hopefully we should see a little bit more of a detailed response in a manner that's quite friendly and quite positive, like all gym instructors should be. Okay, here we go. Fantastic, sweet. So comparing that to the response we got last time, we've got our exercises here. Um, and saying that this is going to help you build muscle mass. And here we've got a little bit more detail. So for increasing strength, it's recommended to do fewer reps and more sets with heavier weights. But for hypertrophy, muscle hypertrophy, so that is like a specific fitness term, the higher rep ranges are more effective. And there's also, good advice like proper form, focusing on proper form, technique to avoid injury, maximize results. So there we've added a little bit of a persona to our prompt to make it a little bit more natural, a little bit more intuitive to the application that we're trying to build out here. Cool. Now, what we can do is to increase the effectiveness further, we can actually provide instructions to our large language model to assume roles when generating responses, and then provide requests and responses as an example. And then using the semantic kernel, we use a special syntax to define user roles. So what I'm going to do is I am just going to, I'll do a little bit of copy and paste, actually. I'll just copy and paste over this. Cool. So what I've done here is I've provided a little bit of an input. So this is an input saying, okay, I enjoy compound exercises using the barbell, and I tend to avoid exercise machines. And then before I've said, okay, I've added a bit of a persona. So the following is a conversation with an AI fitness instructor. The instructor is friendly, positive, and knowledgeable. And what I've done here is I've assigned some roles, giving an example to our prompt. So the user would say, can you give me a list of leg exercises that will help me build my leg muscles? And the assistant will say, okay, of course. Do you have any exercises that you know and love to do? And then I've provided this input to our prompt. So let me run this again. And here we go. So yeah, I provided a little bit of a context to my large language model. So it's responded saying, "Yep, barbell exercises are a great way to build leg muscles. Here are some exercises you can try." And all of these exercises are specific to barbell exercises. So before we might have seen like leg extensions, leg curls. Those are typically exercises that you can do on the machine. But here now we've just got exclusively barbell exercises, which is fantastic. And that means we can actually refine our prompts even further by providing that persona to the semantic kernel. Awesome. So these prompts have worked really well for us so far. This is all in line. But as you can imagine, as our project grows, we'll want to create prompts and save them to files. We'll also want to use variables and calling functions inside our prompts, or inside our prompt templates as well. So what I'm going to do is I'll just expand the Solution Explorer a little bit. And we are going to add some folders. So I'll add a folder for prompts, not plugins, prompts. And inside that, I'll add another folder, and that's going to be called exercise plugins. And these are all going to be custom plugins that we're going to add to our exercise plugins. And then what I want is I want one for get exercise. Also want one for to suggest exercise as well. And then I want a folder for suggest. I'll call it body exercises for now. Not the greatest name I know, but it'll be more. I'll explain it as I go along. So what I want to do now is that to create our prompts, we're going to need two things. We're going to need a config.json file, and an skprompt.txt file. So we're going to start with the get exercise plugin. So what I'm going to do, I'll just add a new item there, and I'm going to call it config.json. I'm going to do a little bit of copy and pasting here. Here I'm pasting in the configuration for this particular plugin. So what I've got is it's going to be a completion type of plugin. I'm describing it, saying, okay, it's going to identify the body area of the user's exercise plan, and it's going to have an input, so text from the user that contains their desired body area for exercises. Cool. And now what I need to do is just add another item for our skprompt file. So text file. And what I'm going to do is just copy and paste that into there. Cool. So what I've got, just make sure that all looks good to me. Yes, it does. Cool. So here, there's a couple of roles that we've defined in this text file. And this is going to help filter the user input and just receive just the exercise from the text. So essentially, the instructions are identify the body area that the user wants to exercise. And an example question of that is, can you give me a list of exercises that will help me build my muscles? And the assistant will be, of course, do you have any exercises that you know and love to do? And then it will just retrieve exercises based off the input. Cool. So now let's switch over to suggest exercises. So what I'm going to do, again, this is going to be very familiar to you. I'm going to create a config.json file. Again, I'm going to copy and paste. I do apologize, but essentially what we want to do here is just recommend weight exercises to the users. And our input will be the details about our user's body area that they want to exercise. Again, we're going to add another skprompt file. There it is. Again, copy and paste. I know it's not fantastic, but what I want to do is just add that. Let me format that a little bit. Cool. So this gives a following example. So following is a conversation with the AI fitness instructor. I'll just remove that hanging semicolon. So yeah, it'll be a good example. Give me a list of leg exercises that will help me build my leg muscles. And then again, our assistant and user will interact with each other. And then finally, in the body exercises, again, we'll add another config.json file. The one thing that I love about this is recommend activities. I'll just change that. Recommend exercises to the user. One thing I love about this, there's a real separation of concerns between kind of our code and actually configuring our plugins. That's users exercises, add that, and exercises. There we go. Cool. And now finally, what I want to do is add another skprompt file. And we'll actually write this out. So you are a fitness instructor. You are helpful. And positive. And I'm going to say, consider your previous conversation with the gym goer. I'll say gym goer. Make it nice and simple. Hopefully I'll recognize it. And then what I want to do is then add this function. So in this prompt, what we can do is we can actually add, I'll copy and paste this, make life a little bit easier. We can call other functions using the semantic kernel prompt template syntax. So there, I'm essentially using this conversation plugin, summary plugin, and summarizing the conversation based on the history between the user and also the system itself. So the gym goer would like some exercise recommendations along with sets and reps. That will help them to increase their strength. Please provide them with a list of exercises, I should say, they can do in the gym. There we go. And we can, if we actually go ahead, I'll just save all of that. Let me check. That's the input. Get exercise config. Cool. So exercises. No, we'll just leave that out for now. Okay, so if I go back into my escape prompt file, cool. So here we go. We're actually using this kind of function here to summarize the provided conversation history. Cool. So now that we've actually created our prompts, let's import and test them. So what I'm going to do is go back into my program.cs file. I'll actually go back to 100 for this. Get more real estate going here in Visual Studio. And now what I want to do is I will copy and paste this a little bit. So instead of all of this, I'll actually go, how do I want to do this? I'll get rid of the conversation summary plugin. I'll build my kernel first. Make sure I'm getting everything there. Okay, so what I've done is I've imported my plugin from type, so conversation summary plugin, and then I'm importing my plugins from a prompt directory. So what I might actually do is just make sure that all of these will build to the output or copy to the output directory when we build. Cool. So I'll go back into my Solution Explorer, go back into the program.cs file. So, okay, so I'm importing my plugins from that prompt directory. Then what I want to do is store the user's conversation history using this chat history object and then pass some information into this suggest exercises prompt and then record the results. So here, so our input is I want to build my leg strength. I love barbell exercises and compound exercises. Cool. So let's run this. Okay, so I just cut it because I've got a bit of an error. It's not suggest exercises, it's suggest exercise. That's the problem with copy and paste. So let me run that again. We don't make mistakes. It's happy little accidents until they land in production, and then we get a call out for it. So here we are. So there is some additional exercises that we can add to our routine. So squats, lunges, deadlifts, calf raises, leg presses, love all of these. So here, by what we've demonstrated here is that we've actually created our own kind of custom plugins that we have tailored to have specific knowledge for those particular that we want our kernel to have. And there we're starting to build out a little bit of the beginnings of an AI fitness assistant. And what we can do is we can actually try changing the input for getting exercises, suggesting exercises, and see how the large language model responds. Awesome. So that wraps up our demo. So in this video, we talked about how we can use built-in plugins in Semantic Kernel. We also talked about how we can use prompts and craft prompts to get the best responses from our large language models that we use in our Semantic Kernel. We also learned how to create our own custom prompts to further tailor our experience for our users. Now, if you want to learn more about the Semantic Kernel SDK and how prompts work, I've left a bunch of resources in the description, so please check that out. If you have any questions, feel free to drop them in the comment section below. If you like this video, give it a like. And if you want to see more videos on Semantic Kernel, don't forget to subscribe. No matter where you are in the world, I hope you're having a great day, and we'll see you all next time.